If you want to see the universe close up with your own eyes, you're probably thinking about using a telescope, some kind of big tube with an eyepiece where you squint through one eye. What if I told you you don't actually have to squint, that you could zoom in just as far, but enjoy the view for hours instead of seconds, and that the view could be brighter, sharper, and more vivid? That you could be completely comfortable, notice tons more stuff, and see deep space objects with the same level of detail as a big telescope, but also as part of a much larger visual composition. What if there was a way to completely redefine the amateur astronomy experience? This is Analog Sky's new stargazing binoculars called Bloom. Bloom uses 8-inch mirrors to collect light, making it the biggest binocular model in the world. I'm Robert, I'm an Oregon telescope builder, and I designed Bloom so the world could see the night sky in a whole new way. So today, I'm going to talk about how big binoculars compare to a telescope. The first thing people ask is, how much better is an 8-inch binocular than an 8-inch telescope? Is it better than a 12-inch telescope? A 16? Most of the people who try to answer these questions online are not binocular telescope users. They're usually one-eyed telescope users who've spent an evening with a big homebrew binocular, maybe an hour total of actually looking through it. Some haven't even looked through big binoculars at all, and they're just going by math. Or maybe they have a binocular attachment for their telescope, which is a totally different thing. I've spent the last 7 years using only binocular telescopes and comparing them to the View and Friends telescopes. So I'm going to answer those questions, but I'm also going to debunk the math with actual descriptions of what it's like to see various deep space objects and talk about why these are actually kind of the wrong questions to ask in the first place. I am going to answer the question in a different way. If you told me I had to choose between these 8-inch binoculars and a big Dobsonian telescope, how big would the telescope have to be? So grab a beverage and let's start with brightness. Brightness means you can see more things, more details in the things you could already see, everything bolder and brighter. And at night, mammal brains combine the light from both eyes into one brighter impression in your mind. That's how everyone from tiny rodents to a human night fisherman finds their way around on a moonless night. The next time you are in a dark place at night, look around at the detail in the trees, the rocks on the ground, the contrast of a patch of snow, or even a dim star. Then close one eye, and it all goes away. Now, the question you have as a consumer making informed consumption choices is how much? How much brighter is it than an 8-inch telescope? Could I buy a 12-inch telescope and see the same effect? Can I get the same effect with a binocular? Now, telescope fans, being engineers, scientists, and other number-oriented people, love reducing complex questions like that to number-based answers. So there's this concept called binocular summation factor that comes from military research. It's a single multiplier that, when applied to binoculars, means for a given mirror or lens size, you can see as well using a single larger mirror. And that number you usually hear is 1.4x. So 1.4x the size of the binocular mirror to get the size of the single mirror of equal brightness. So let's do some math together. So binoculars with 10-inch mirrors would be equal to a 14-inch telescope. Analog Sky's 50mm binoculars would be equal to a 70mm telescope. Our 80mm binoculars would be like a 4.5-inch telescope, and Bloom here with its 8-inch mirrors would be like an 11.2-inch telescope. Okay, that's easy math, but is it true? Well, no, not at all. I'm going to describe my experience looking through these 8-inch binoculars in, well, descriptive terms. I'm not an engineer or scientist. I was a graphic designer for 20 years, so I like communicating through more concrete sensory experiences. After all, that's what we're doing here, enjoying our senses, right? I'm going to use Stellarium, the free desktop planetarium, to help me visualize the views. Just so you know, I do most of my observing at dark sites in Oregon's beautiful backcountry, usually at least a 21.2 on the sky quality meter. I have really bad astigmatism in both eyes that's mostly corrected by glasses, but still leaves enough flare that I'm not the world's most enthusiastic double star chaser. So that's the context for what I'm about to say. And of course, I'm just one person, so if you are an Analog Sky community member listening who's built one of our 50mm or 80mm binocular telescopes, why not leave a comment below about how they compare to a 70mm or 4.5-inch telescope. So let's go. What's wrong with reducing the whole binocular astronomy experience to a coefficient? As you can probably guess, it's wrong in more than one way. So let's start with why using the number itself doesn't really work at all. Then we'll move on to why even thinking about it in these terms is not very helpful. 1.4 doesn't work because we look at lots of different things through stargazing binoculars. Big things, small things, bright things, dim things, and all those things get processed differently by our brains. There's no one size fits all. The exit pupil of the eyepieces we're using when we do it also really affects how much light your brain has to work with. If you don't know what exit pupil is, you can click on this video I'm going to make later that explains it. But basically, exit pupil is the little circle of light that comes out of the back end of your telescope that you look through. Now, the pupils in your eyes get big at night to let in more light. If that exit pupil circle matches the big dilated pupils in your eye, then you're seeing the brightest possible image. And if that circle is teeny tiny, then you're seeing a far darker image. Now your brain has a lot less data to work with. So wide low-power eyepieces have big exit pupil, and narrow high-power eyepieces have small exit pupil. Now, I'll never forget the first time I had a prototype 8-inch binocular out next to my friend's 16-inch f4.5 Dobsonian telescope. It was summer, so we were both looking at the Lagoon Nebula. Great dark night at 2,500 feet elevation. He had his 31 Nebulae eyepiece in his, and I had a pair of Morpheus 17.5 millimeters in mine. So we're looking at about the same magnification, and we both had the same DGM nebula filters in. The views looked identical to me in terms of both brightness and detail. But the 1.4 thing, he says, a 16-inch is supposed to be way brighter than an 8-inch binocular. So what's going on here? Well, first, we're looking at a big object that's spanning most of the field. Second, the 16-inch is at 7 millimeters exit pupil, and the 8-inch binocular is at 3.5 millimeters exit pupil. So the 16-inch telescope is fully utilizing your eye's fully dilated pupil with a very large patch of light, but only one eye. The 8-inch binocular is only filling up your pupils partway with the same size patch of light, but in both eyes. And that means your brain can go to work constructing a clear picture from the data. So, we have a point of comparison here. We can say, for a large, bright object, an 8-inch binocular at 3.5 millimeters exit pupil is as bright as a 16-inch telescope at full exit pupil. So that would represent a binocular summation factor of 2x, not 1.4x. Crazy, right? Here's what's even crazier. The 16-inch telescope is pretty much maxed out on how bright it can go at 7 millimeters exit pupil, but the 8-inch binoculars are just getting started. We can still go up to 4 millimeters, 5 millimeters, 7 millimeters exit pupil. Now, of course, the magnifications will be smaller, but for our large object, we don't necessarily mind. Now we're seeing very clearly the wings that point toward the Trifid Nebula. We're seeing the Chinese Dragon Nebula, NGC 6559, off to the left. We're seeing the diffuse globular, NGC 6544. We're even seeing the Trifid itself at the edge of the field, and we're seeing the trail of stars, gas, and dust between the lagoon and the Trifid. We're seeing the Barnard Dark Nebulae, 88, 89, and 296. So we're seeing all this incredible beauty in one scene with crisp detail. So our view is now brighter than even a 16-inch telescope. How much brighter? Who knows? By definition, it's impossible for a one-eyed view to get this bright. This is the first problem you run into defining binoculars in terms of one-eyed views. If you numbers people out there want to quantify it, I suggest going the opposite direction. Call the two-eyed view with the fully dilated pupils 100% and subtract from that to determine the one-eyed view. Maybe it's 60%, maybe it's 30 or 40. Let me know how it goes. Okay, great, but not everything is a large, relatively bright nebula like the Lagoon. Sure, something like the Great Orion Nebula also looks incredible, but what about all the smaller stuff? Okay, so with the nearby Swan Nebula, again, you see a much greater expansive nebulosity around the swan shape than you would see with one eye through 8-inch or even 12 inches. And the dark nebula that makes the swan neck stands out jet black against the nebula in the background sky. One of my absolute favorite nebulae is the Dolphin Head Nebula. You know, the one you only ever see in photos. It's about 40 arc minutes across and looks like a dolphin's head. It's a Wolf-Rayet shell. In a 10-inch telescope, there's barely any hint of this nebula with O3 filter whatsoever. It's so hard to make out. In my 80mm binoculars called Heart, you can make out at least half the ring around EZ Canis Majoris very easily, no problem. So even in the 80mm binoculars, it's much easier to see than a telescope. In Bloom, not only can you see the full ring much brighter, but also the dolphin's faint beak. Going a little smaller, M57 brightens remarkably with both eyes open. That's the Ring Nebula. I know it's a lot of people's favorite. Of everything in the sky, I think this is the biggest shift from one eye to two. Close one eye and it has a very ethereal, ghostly appearance. Open them both back up and it feels searingly bright in comparison. I would take this view over any 12-inch telescope. It's beautiful at high magnification, but even more fun at medium 60x view, where it's an interloper floating through the stars. That's by far my favorite magnification I've seen of the ring, besides seeing it in a 30-inch, that's 30-inch telescope. The planetary in Messier 46, NGC 2438, pops right out with the contrast boost you get from using both eyes. Of course, it even pops out while you're seeing M47 and NGC 2423 in the same field. So you don't need O3 filter, UHC will work fine to see the nebula, and you still get hundreds of stars. Usually with a telescope, you're zooming in much closer, filling the whole field with M46, and then observing the nebula. It's a very different experience, albeit equally bright in a 12-inch telescope. The Emerald Nebula, NGC 6572, is about 20 arcseconds in size. It retains its astonishing teal color to moderate magnification and bloom. So it's amazing. Even at 28x, it looks very stellar, but pops out as the richest color you've ever seen in the sky. But it's pretty small, and you might want to see at least a little detail. The color gets washed out quickly as you start adding magnification, and being so tiny, it gets dim and loses that color faster than it would in a 16-inch telescope. That's because we're shrinking our exit pupil beyond 3 millimeters and we're giving our brains a lot less signal to work with. Same goes for something like the Cat's Eye Nebula. Now, believe it or not, there are nebulae in the sky much larger than the lagoon too. They're usually too big to see very well in a telescope. Can you see them in bloom? Well, let's take a look. Seagull? Yep. Rosette? Yep. Pelican? Yep. California? Yep. Barnard's Loop? Yep. Heart and Soul? Yep. Reflection Nebula and ISM around the whole Pleiades? Yep. Flaming Star? Yep. Angelfish? Yep. All the stuff you can barely get a sense of in a telescope. This is where aperture combined with two-eyed wide views gives you a whole new window on these large objects. By the way, our 80mm binoculars Heart will also show you these huge nebulae in their entirety, along with stunning detail. So with nebulae, I'd say 8-inch binoculars crush one-eyed views in the 12 to 16-inch range, unless we're talking about miserably small planetary nebulae that look like stars. In fact, take Bloom to an outreach event, set up next to your friend's 18-inch Dob, and just show people the exact same nebula your friend is showing, and people will whisper to you which view they liked better. Okay, let's talk globular clusters. M13 is the classic big bright globular cluster Obsession Telescopes has used for years to compare the view in different sized telescopes. They have a little picture that shows M13 looking washed out in an 8-inch telescope, way better in a 12-inch telescope, and then progressively brighter and more zoomed in until you get to their biggest telescope. Honestly, I can't really even tell the difference between the 20-inch and the 25-inch here, but you get the picture. Well, in Bloom, you get a view that's at least as bright and detailed as the 12-inch, but also, at the same time, you're seeing the whole surrounding area, which includes an NGC galaxy, a beautiful star field, and at a dark site, a rich tapestry of interstellar medium, ISM. This is large-scale nebula that spans the sky. It's a challenging, rewarding observation that completes the story of the stellar life cycle. This is the stardust that slowly forms the molecular clouds that give birth to the new stars. Now, the same goes for M22. You see the cluster resolved into hundreds of individual points of light, but you also simultaneously see it flanked by two beautiful wing-shaped asterisms and the tiny globular NGC 6642. Now, I know you've been trained to believe we focus on individual objects when we're stargazing, but think hard. If you could see a beautiful globular cluster busted up into sharp, brilliant stars either way, would you rather see just the cluster or the cluster floating in a field of stars, surrounded by diffuse nebulae, galaxies, and other star clusters? Now, it holds for smaller Messier globs. I feel like go big aperture and zoom all the way in on the core, or zoom out and see the object in its context, but in between is not super satisfying to me anymore. I love M4 in Bloom because you see these long, straight rows of stars that look like they were rearranged by a galaxy-spanning civilization. It is very creepy. Now, it gets smaller and smaller, and again, regardless of overall surface brightness, aperture is required to resolve those stars into little points. If your thing is resolving tiny NGC globular clusters, a 12 or 16 inch is really going to start pulling away from 8-inch binoculars the more you zoom in. There are a million really big open clusters to enjoy in big binoculars. They look way better in binoculars when you can see the space around them. Telescope people have told me, aren't open clusters just more stars? And I guess if you're so zoomed in that it just looks like a slightly denser star field, okay. Maybe it's not that interesting to look at open clusters. 8-inch f5 binoculars with 1000mm focal length still give you that 30 to 60x magnification range, where an open cluster is an object in the field, but not taking up the whole view. And that makes them look like globular clusters, but with far more interesting shapes and star patterns. You can see an open cluster like M67 at 60x with its ancient reddish stars glowing so vibrantly. At maximum exit pupil, you're seeing Matariki, or the Pleiades, in their entirety in one field, but also surrounded by reflection nebula and IFN and ISM. This is not a view you can replicate in a telescope, even with the Binocular. Okay, planets are bright in just about any telescope, so it's really about resolution and minimizing optics between you and those tiny full-color details. You're trying to zoom in a bunch, and you have to either track or chase the planet and its moons. The question is, what do 8-inch binoculars give you that a 12-inch telescope wouldn't? Well, here in the northern hemisphere, where most people live, the ecliptic plane where planets hang out is stuck in the lower part of the sky for much of the year. That means more atmosphere to look through and wavier images from the turbulence in the atmosphere, what we stargazers call poor seeing. Looking through two separate telescopes simultaneously means you're literally seeing different pictures that have passed through two different columns of air at the same time. And your brain takes those two pictures, finds the sharpest details, and throws out the blurry parts while retaining the overall brightness. So, while a 12-inch or 16-inch telescope have higher resolution on paper, sometimes the image you see in your brain is consistently sharper through smaller binoculars. And this is even more valuable in humid climates where seeing can get really bad. Now, a binoviewer might attach to a big Dobsonian scope, but it doesn't magically merge two different images into one sharp image. Also, experienced planetary observers know it's like fishing. You're sitting there waiting for short moments of superb seeing, where all those tiny moons, festoons on Jupiter, the gaps in Saturn's rings, or literally anything on Mars suddenly snaps into place. Now, when you're squinting through one eye, you have nowhere near the stamina you have with both your eyes comfortably open, so you catch a lot more of those moments of perfect seeing. And of course, when you're able to keep both eyes open, things also end up looking bigger in the eyepiece. I feel like planets get a 30-ish% boost in how big they feel through both eyes. So you're able to use less magnification to see the same amount of detail, which means less eye floaters, a brighter image, it's easier to follow, and it's going to look crisper anyhow. So while Bloom has a 33% central obstruction and an extra set of mirrors to bounce off of, I'd say the two-eyed view still wins for me until you get to a really big telescope, something like a 20-inch mirror with tracking that can do 500x and drive a truck between Neptune and Triton. Just, of course, keep in mind, it's not every night that the sky can actually show you 500x. Okay, let's talk galaxies. Andromeda looks great. Not only can you see the surrounding galaxies, you can also see SDSO1, the newly discovered enormous ghost planetary nebula surrounding the galaxy, as long as you have filters and reasonably dark skies. I haven't seen more detail in Andromeda than Bloom until you're able to really zoom up to the core to see the dust lanes clear in a 16-inch or better. Still, of course, my favorite view of this triple galaxy is 15x through HART, the 80mm, because you can see the full warped disk, the surrounding star field, and a trail of ISM leading down to N33. Bigger isn't always better. M81 and M82 also look at least as good as a 12-inch. You get the feel for the spiral of M81, and NGC 3077, the Garland galaxy, is bright enough that this looks like a triplet in Bloom with my 26mm Masuyama eyepieces. It's much steadier in Bloom than a 10-inch telescope. Now, M51 is quite a bit smaller though, and this is where we're zooming in to get a better view and shrinking those exit pupils again. And here, a 14-inch or even a good 12-inch starts to pull away from Bloom because you're seeing more of that arm structure, that delicate arm structure. I'm not saying I don't correctly assess the spiral direction every time looking at it in Bloom, but the structure at these small exit pupils is clear in a larger aperture scope. Now, going smaller, I just saw the supernova in NGC 7331, and that was a fabulous sight. Really nice galaxy in bloom. However, there were only faint signs of the neighboring Deerlick galaxies, and Stephan's quintet was also very baby, without very much detail at all. So, small galaxies are one subject where they're so small and faint, our brain's complex image processing software isn't getting enough data to give a good two-eyed view, a meaningful boost over the native 8-inch image captured. So the view is certainly better than when you close one eye, and you're still able to focus better on the scene with both eyes open. But I would say if your favorite thing is finding all of the identical-looking Herschel galaxies at the very edge of perception, one-eyed aperture is going to serve you better until I have the 16-inch binoculars ready to go. Okay, dark nebulae aren't popular stargazing targets for two reasons. Number one, you need dark skies to see them. In fact, they're the best sign of a truly dark sky. Number two, they look terrible through one eye. Even modest binoculars are vastly superior to immodest telescopes. It's that brain contrast detection pipeline again. They pop right out with two eyes, really hard to see with one. I don't know how many nights I've been out with my 80mm binoculars surrounded by 10, 14, 18-inch telescopes, and the views of dark nebulae were so much better. So when you bump up your binoculars to 8-inch size, yes, you're already seeing dark nebulae better than any amateur telescope you could possibly hope to buy. Get a $100,000 24-inch RC, build a $200,000 observatory around it, it won't help, with maybe one exception, which is the incredibly small, faint Horsehead Nebula. Now, if that's the only dark nebula you've ever heard of, Beverly Lynn's cataloged 1,802 of them, and almost every single one of those is more fun to look at than the Horsehead. So, when you see dark nebulae through binoculars, they also look much darker than the background empty space. You're seeing real three-dimensional depth to the Milky Way when you trace those dark filaments against the stars behind them. The rift between the North American Nebula and the Pelican Nebula that give them their distinctive shapes is a dark nebula. In binoculars, you can see very easily it's between us and the emission nebula. Now, of course, I delight in the fact that my binoculars have this huge advantage, so I love looking at dark nebulae. But also, keep in mind that dark nebulae are where stars come from. Dark nebulae are the darkest, coldest places in the universe. And stars, these impossibly bright, hot objects, suddenly pop into existence because a cold, dark nebula reaches a tipping point. Isn't that wild? I love scanning the sky for all these dark clouds, and binoculars really open up a whole new category for you to explore. Okay, so here's the thing. Comparing binocular views to telescope views is missing the point because looking through binoculars is just an entirely different experience. I've shared some specifics about individual objects, and hopefully that's helpful. Big telescopes definitely have their advantages. I'm not saying big binoculars completely replace everything a 14 or 18-inch Dobsonian can do. But when it's time to express the overall binocular experience, different things emerge beyond simple brightness and detail. The big thing is, it's about 1,000 times more comfortable to look through both eyes than one. Being comfortable means you can focus on details better, which means you need less magnification, which means brighter, wider views where you're taking in so much more. The scenes I'm seeing are so different from what my friends are taking in through their telescopes. Even familiar objects feel different and brand new. So this comfort factor also transforms your goals and how you approach astronomy. When it's more uncomfortable to squint through one eye, you tend to spend a lot of time planning what you're going to look at, work on finding that thing, and then taking your peeks at that thing and trying to create kind of a rational scientific description of it to give your stressed out brain something to focus on besides the discomfort. But if you're comfortable with both eyes open, you can just pick a spot in the sky and go exploring for stuff. It's exciting to bump into something unfamiliar and then zoom in on it. With Bloom, a lot of times the built-in Pi Finder can tell you what that thing is. And beyond the adventure, the views are just breathtaking, beyond words. You don't have to give yourself busy work when you're outdoors on a beautiful night, spellbound by the sight of our awesome universe. You can just be. And if your thing is outreach, showing people big showpieces through Bloom is just hour after hour of wow after wow after wow. Oh, so if you told me I have to choose between a Bloom or a big telescope, how big would the telescope need to be? You know, I hang out with people with really big telescopes. I'm regularly looking through 18-inch, 20-inch, 25-inch, sometimes even a 30-inch telescope. I really think it'd have to be at least a 20, but maybe a 25. I really, it would have to show something that's so far beyond what I can see through 8-inch binoculars to make it worth it. Yeah, it would be somewhere in the 20, maybe in the I don't know about 20. Maybe a 20, probably 25, probably 25. Maybe a 20. So this is my invitation to ask yourself, what do you want your stargazing experience to look like? How do you want it to feel? Are you looking for an immersive, aesthetic, exploratory experience? Do you want to drill down and just focus on the object itself, or do you want to see it in the wider context of the sky around it? Do you want to wander and discover and get lost in your thoughts? Now, up until now, the only way to get a binocular of this size was to homebrew your own, spending thousands of hours learning telescope design and prototyping a lot because there are no step-by-step guides about how to build your own binoculars. And through the miracle of 3D printing and CNC metal fabrication, Analog Sky is working hard to bring the world something all new. You get to experience the fun of building your personal spaceship and get the benefit of an experienced telescope builder and a whole community of other binocular builders working together to make it the best it can be. It's a great way to join the tradition of astronomer/telescope maker. So if that sounds like something you're into, come join Bloom's early access campaign. We're trying to find 60 people who want a whole new way to see the universe. And if you're not ready for Bloom, you can check out our smaller models in our other YouTube videos or at analogsky.co, and even sign up for free in our community at members.analogsky.co, where you can see what we've been building together. Like and subscribe to keep an eye out for more videos about Bloom. Until then, clear skies.